Howdy, Trig. Today we're going to be going over the unit circle again. We're going to do a right angle approach this time, just to complement what we've already been going over. We've already been over the unit circle using the unit circle approach, using the equation for the unit circle, and so this can be a little bit more geometric than that approach, and we look at these from different angles, so to speak, so that we get a better idea of where all these values are coming from. So let's go ahead and take a look at this approach. This one we're going to use triangles. First we have an isosceles triangle with a hypotenuse of 1. Then we use an equilateral triangle. And we're going to use that to fill in this unit circle on the back side of the handout here. And you may notice that I have these at pretty much the same scale. Unit circle is a radius of 1. And you may notice that's about the same length as that right there. There we go. Our right triangle of 1. So here's what we're going to do. We are going to calculate the sides. Now we know that it's an isosceles triangle, so it means this side and this side are the same. And so that means we go, a squared plus b squared equals c squared. Notice that a and b are the same, so we can just write this as a squared. And our hypotenuse is this 1 right there, so that's just going to be 1 squared. So we have 2a squared equals 1 squared. Of course, that's just 1. And so we end up with a squared equals 1/2. And so a equals 1 over square root of 2, multiply root 2 over 2. And so we get that a equals square root of 2 over 2. So we've got those two sides. So we got square root of 2 over 2, square root of 2 over 2. Now the sum of the angles in a triangle, well, that's going to be 180 degrees, which is pi radians. And so it's the sum of all three angles in the triangle. Well, we know that one of the angles is 90 degrees, or pi over 2, if we're using radians, which we're going to go ahead and do this in radians. So pi equals, and the other thing we note is that this angle here is the same as this angle here, right? So we can go ahead and call those both alpha, and so this is going to be 2 alpha plus pi over 2. We start working through this, and we get 2 alpha equals pi over 2 divided by 2, and we get alpha equals pi over 4. So we know that both of those angles are pi over 4, and that is the same as 45 degrees. Okay, so now we can go ahead and calculate sine and cosine of this angle. Remember, sine alpha, we'll use this angle, but it's going to work out the same for both of them. Sine of alpha, that's going to be the opposite over the hypotenuse. Note the hypotenuse is just 1. So this is going to be root 2 over 2 divided by 1, and we can just ignore that 1. And so we've got that sine of alpha. What is alpha? Alpha is pi over 4, or 45 degrees. And note for cosine of pi over 4, well, that's also going to be the same. It's going to be the adjacent this time. Root 2 over 2. Just like we got from the other approach. Alright, let's go ahead and throw these on the unit circle on the reverse side. Okay. We'll zoom in on here. And so we already have had some experience with this. This does form a right triangle. Remember, we use right triangles when figuring out the equation for a circle. X squared plus y squared equals the radius squared, which is 1. And so, again, this is 1. The distance from here to here, well, that's y. Distance from here to here is x. And so when you go, and here's our angle right here. It's 45 degrees, but we're going to keep it as a variable for right now. So whenever I say what is cosine theta, well, that equals the x coordinate, right? It's the x coordinate divided by 1. If I say what is sine of theta, well, that's the y coordinate divided by 1. Okay. So let's look at this point, right? We're looking for x and y. And what are x and y? X and y are cosine of 45 degrees and sine of 45 degrees, right? 45 degrees is pi over 4. We just worked that through, and that's root 2 over 2 and root 2 over 2. And so that's the coordinates for that spot. All right. And, since we're over here anyways, let's go ahead and just put that in. Obviously, that's 1 and 0. And clearly, this is 0 and 1. All right, so let's look for these 2 points. And we do that with this other triangle that we've drawn here. Now consider the equilateral triangle with sides of 1. So that means this side is 1, this side is 1, and note we've got this bisector here. It's an equilateral bisector because we got 2 equal parts, so we've got 1/2 from there and 1/2 to here. Okay. Next thing we want to do is figure out, okay, what are all the angles? So, equilateral triangle, all the angles are exactly the same. Sum of the angles is pi, right, or 180 degrees. And so our angles are simply pi over 3. Alright, so what we're going to do, so again, pi over 3, pi over 3, we're going to go ahead and take a look at this mini triangle inside. And we want to know, okay, what is that angle there? So we use the same trick. And so the sum of the angles is pi. That one's, pi over 2, or 90 degrees. It's a right angle. So we've got pi over 3 plus pi over 2 plus our own known angle. Let's call that one alpha for right now. Alright, so we're going to go ahead and work this one. We got pi equals 5 pi over 6 plus alpha. Subtract 5 pi over 6 from both sides, and we get that alpha equals pi over 6. So that's what that angle is right there, pi over 6. So note that this is the same thing as 30 degrees. And note that this is the same thing as 60 degrees. Alright, now let's go ahead and calculate the height of this guy. And we're going to use nothing more than simple the Pythagorean's theorem. So this is, h squared plus 1/2 squared equals 1 squared. Right? Pythagorean's theorem, plain and simple. So this turns into h squared equals 1 minus a fourth, which is 3/4. And then we take the square root of both sides. And so h equals root 3 over 2. Now, I'm not taking the minus since you can't really have a negative height. Okay, now we're going to use this to find various cosine and sines. So the cosine of pi over 3. So again, this is going to be adjacent over the hypotenuse, which we found that over here. Let me go and write that in. Alright, so cosine of pi over 3, again we're looking at this angle here, so that's going to be the adjacent divided by the hypotenuse, so it's simply 1/2. And then the sine of pi over 3, that's going to be the opposite over hypotenuse, so root 3 over 2 all over 1, which of course is just square root of 3 over 2. And we already knew that from before, of course, but this is just another way of looking at the same bit of information. Let's go ahead and take a look at this angle now. And so now we have, we'll do cosine first. Cosine of pi over 6. Adjacent to pi over 6 is root 3 over 2, so we got root 3 over 2. Hypotenuse is 1, so it's simply root 3 over 2. And then sine of pi over 6, that's going to be the opposite, so we got 1/2 over 1, so sine of pi over 6 is simply 1/2. So we're going to use this information to fill in the rest of the quadrant. So we come back down here. And so for this x and y coordinate, now this is 60 degrees, and we've already discussed that this is going to be pi over 6, this is pi over 4, and then this is, I'm sorry, this is, I meant to put 3 there, and then this is pi over 6. Alright, and so this one we go, okay, well what is the cosine of pi over 3, or 60 degrees, and sine of 60 degrees, because again, these are just the x, end up being the x and y coordinates like we discussed earlier. And so we go, okay, well what's cosine and sine of 60? That's over here. And so this is just 1/2, and then with a y coordinate of root 3 over 2. Simple, simple. And in this one here, it's just swap them. Root 3 over 2 and 1/2. We got it. Alright, that's the first quadrant. A slightly different approach than what we did in the last handout, but it's important to understand both of them. Alright, now we're going to go ahead and use this information to fill out the rest of the unit circle. Here, note both x and y coordinates. They're both going to be positive, positive. Here the x coordinate will be negative and the y coordinate will be positive. And so we're just going to go ahead and use what we know from the first quadrant. Note that this is in the same line, same amount over to the left. So we're just going to put the right sign, but keep the numbers the same. And then same here, negative root 2 over 2, positive root 2 over 2. Just like so. Now for the angles, note that if we go halfway around the circle, we're at pi. So we're always going to be needing one more slice of pi, is the way I like to explain this one. So over here, this is pi over 3. Right, the pi is divided into 3 pieces, and so it needs just one more slice to be a whole pi. So we put a 2 pi over 3 there. This one, note just going right in line with it's symmetric with the first quadrant. We have a pi cut up into 4 pieces, and we need one more for a full pi, 3 pi over 4. And then over here, pi over 6, and we're just one piece of pi short, because note that this angle right here is pi over 6, and that's what you need to get a full pi. Okay, so that handles that one, that quadrant. Now let's look at quadrant 3. Note that this is the quadrant where both x and y are negative, but the magnitudes will still be the same, because again, each quadrant is symmetric to all the other quadrants. And so this is negative. You can look, notice this one's the one that's in line. So we've got a negative root 3 over 2 and a negative 1/2. And then we got negative root 2 over 2 and negative root 2 over 2. And then on this one we've got a negative 1/2 and a negative root 3 over 2. Now note on these we've got a whole pi, and then we got an extra slice. Whole pi, note right here, that's just an extra pi over 6. So what we're going to do, got our pi divided into 6 pieces. We got all the pieces, and we got another piece from another pi. And so here we got pi over 4 with an extra slice. Alright, this next one here, we got pi over 3, but we have a nice extra slice there. And it even goes to this one, 3 pi over 2, for that extra slice of pi. And so this one's 0, and negative 1 are the x and y coordinates. Now we go to the fourth quadrant. Note for this one that the x's are positive and the y's are negative. Positive, negative. And so we just make sure the magnitudes are correct and that the signs are correct. So we've got, the x is 1/2, right in line with this one here. So 1/2 and negative root 3 over 2. And then right here, positive root 2 over 2, negative root 2 over 2. And then we've got positive root 3 over 2, and then negative 1/2. Okay, so far so good. And now let's go ahead and fill in the pies. Note that we are one slice short of having 2 whole pies. And so we got pi over 6. We need 12 slices to have a whole 2 pies, so we have one less than that, 11 pi. Pi over 4, 8 slices for 2 pies, 1 less. And then right here we got pi over 3. We need 6 pieces to have 2 pies, so we have 1 less than that, 5 pi over 3. And that's the unit circle. This is the right angle approach. Please make sure you watch the next video in short order about the cosine and sine functions.